So there's a student who's drinking out of a cylindrical cup, so something like this. And what we have here is the cup is at an axis at a vertical rate, or it's being drained at a rate of 3 cubic centimeters per second. If the cup's at a height of 10 centimeters and the diameter of its opening is 6 centimeters, all right, so total height's 10 centimeters, and the diameter of its opening, so across here, 6 centimeters. How fast is the level of liquid falling at a depth of 5 centimeters? So right snap dab in the middle. So we've got 5 centimeters here. All right, so there's something we have to do here because we're going off of height, but in order to find volume, you always use a radius. We need to represent the height we need to represent the radius in terms of height. So starting at, the general volume is 1/3 pi r squared times h, and then our ratio between the radius and the height is r over h is equal to 3 over 10. And then in this equation, if we solve for r, we multiply both sides by h, and we get radius is equal to 3h divided by 10. So we'll sub this back in for r in the equation here. So v is equal to 1/3 pi 3h over 10 squared times h. Yeah, if we want, we can multiply this out. So 1/3 pi times 9h squared. Actually, take that back. 9h cubed, because we add in that h, over 100. All right, so if we take the derivative, dv dt, and then dh dt on both sides, so we get dv dt, so the volume with respect to time, and then 9h. So if we take the derivative of that, it pretty much cancels out the 1/3, so we end up with 9h squared pi all over 100, because this 3 came down, it canceled out that 1/3. All right, and we want to know what the height at 5 centimeters, so we just sub in h of 5. So in this instance, dv dt is going to be equal to 9 times 5 squared times pi over 100, which gives us, it simplifies down to 45 over 100, which becomes, let's see here, I just realized I made a small mistake. dt should be here, and we want to know, oops, not there, but here, dh dt, and we wanted to know what the liquid was. And I already knew what this was. This was 3 centimeters cubed. So actually, and ultimately, so what we do here is we take, it ends up being dh dt, which is right here. And then what's going to happen here is I'm going to divide 3 divided by 9 times 5 squared pi over 100, and we get 3 times 100 over 9 times 5 squared. I'll fix that for us. All right, I got it. And then basically 25 times 9 is 175. And this breaks down into 4 over 3 pi, or roughly 0.42 centimeters a second. And that's how fast it's going down at this point. All right, I hope that helps. Thanks for watching.